Hey everyone, so today we're going to work on graphing rational functions day 2. And the first thing I want to do is just do a little warm-up with finding vertical and horizontal asymptotes. If you completely forgot how to do this, friendly reminder, if you scan back up, you have hints on how to find vertical asymptotes and how to find horizontal asymptotes. So I'd like you to pause the video and you're going to work on these 6 here. I labeled them A, B, C, D, E, F, just so you know if any questions are asked. And I want you to find the vertical asymptote, there could be more than one, and the horizontal asymptote for each of these functions. And when you're ready, you can press play. Okay, so now that you're done with these, here are the answers, rather. Okay, and just want to go through these quickly. Again, this should be a review. So reminder, if the bottom degree is bigger, okay, then we have y equals 0. That was this case and this case. X squared is bigger, so this is y equals 0. In all other scenarios that I'm going to be giving you this year is we look for the, if it's the same power, we look at the leading coefficients. 3 over negative 2. This one is 1 over 1. This one is, don't forget that negative, 4 over 2, which is negative 2. Negative 1 over 3, which is negative 1/3. So that's for horizontal asymptote. And again, there can only be one of those, so don't look for more than one. Vertical asymptotes, set the denominator to 0. Negative 1, negative 1/3. If we have multiple factors, then we set each one of them equal to 0, and we're going to have 2 vertical asymptotes. Okay, and factoring something like this, don't forget if you did like divide and slide or split the middle, make sure that you factored correctly there. 2x minus 5, x plus 2, so you get 5 halves, and x equals negative 2. Again, notice that I wrote all of them as equations. Y equals and x equals, yes, you have to do that. Okay, so going off of that factoring idea, pause if you need to correct anything and make sure you check all of your answers. Going off of that idea, we're going to talk about point of discontinuity, fancy word for saying there's a hole in the graph. Okay, this is an undefined x value that we plot as an open circle. So we are going to plot it on our graph, even though it's actually a hole. And it happens when a factor cancels out from our rational function. Okay, after we cancel, we always use the new function for the rest of the problem. So let me show you what I mean. So above when you factored, nothing canceled. But for this example, we would have x plus 3 over x minus 1. Okay, so we cancel. Okay, that moment is telling us there is a point of discontinuity, or you could say a hole in the graph, and it's at wherever you canceled. So you canceled an x minus 1, and that represents an x equals 1. It's kind of like setting it to 0. So the point of discontinuity is at 1 comma something. So point of discontinuity at x equals 1. We do want to find that y value. Our function we're going to use for the rest of the problem is this. Okay, so we're never going to use this again. So don't look at it. Okay, we're going to plug in x equals 1 to this. So f of 1 would be 1 over 1 plus 3, which is 1/4. So I have a point of discontinuity at 1/4, 1 comma 1/4. If I asked you about vertical and horizontal asymptotes, horizontal asymptote, I hope you guys would say bottom degree is bigger, so y is equal to 0. Vertical asymptote, when is the denominator equal to 0? When x is equal to negative 3. Notice I didn't care what was happening here. That's because it canceled. I was done with it. This is the function I want to use. So it only has one vertical asymptote at negative 3 because of this is the equation we're referring to. And it does have this point of discontinuity at 1/4. Okay, let's try one more of those and then we'll actually graph one of these. So here's f of x, and again, notice that the top degree is bigger than the bottom, which we don't really have a rule for. It's technically called an oblique asymptote. We're not going to be graphing these this year, but in a general sense, you might guess that it's an oblique asymptote. So you're like, oh, okay, or like something is special, and you try to do the asymptotes. The first step in doing these problems is you need to try to cancel and factor first. So we factor. Notice it's just slightly different than the one we did. X minus 1's cancel. This tells us there's a point of discontinuity at x equals 1. Okay, 1 comma something. And what do I have left, guys? Notice I have left x plus 3 over nothing or over 1. This is just a line. So are there any vertical or horizontal asymptotes? No. So there are no asymptotes here. Okay. And we still can figure out what we're having, where we're going to have that point of discontinuity. F of 1 would be x plus 3. 1 plus 3 is 4. So you're going to have a hole at 1, 4. Besides that, I would just graph the line x plus 3. Okay, so we're going to try out 2 examples below where we actually graph these, and then we'll see how it's going. So again, this is something you're looking out for. Remember, as we learn new things in this chapter, it's not that like every single graph is going to have a point of discontinuity. It's just something we could see as we go. So take a look at, we've got 4 examples here. We're going to try 2 together. And that first one, x squared plus 4x plus 3 over x plus 1. Again, before you attempt any of this, you want to first try to factor. So this is x plus 3, x plus 1 over x plus 1. Hey, look, it cancels. What do I have left? I just have that x plus 3. So we're going to see this in action here where, again, this is just a line. There are no vertical asymptotes. There's no horizontal asymptotes because there's no fraction of polynomials. X plus 3 over 1, we're not going to make this complicated. We're just going to say it is a line. What canceled, guys? Point of discontinuity is going to be at -1. Again, you set this to 0. When is x plus 1 equal to 0? We plug that into f of x. F of -1 is -1 plus 3, which is 2. Okay, so that's this answer. We just discussed that there is not a vertical or horizontal asymptote because we basically ended up with a line. This doesn't always happen, as you can see from this example, right? We had a point of discontinuity and we had asymptotes. So what do we got here? Y-intercept. Well, x plus 3, the y-intercept is 3. I mean, you could still do that little trick of setting x to 0, but hopefully you recognize this as mx plus b format. So b is 3. That y-intercept, we'll write that as 0, 3. What's the x-intercept? That's when you set the whole thing to 0. That would be when x equals -3. And honestly, when you're graphing a line, you could just find the intercepts after you graph. So we are going to graph the line x plus 3. So we start at 3. Okay, and one note, make sure at -1, 2, it should be on the line, which it is, should be an open circle. Sorry, that was really poorly drawn. Okay, should be an open circle because that's a hole in the graph. You would just continue the graph because it's a slope of +1. You know what that looks like. We hit our x-intercept, and then I just graph the line. So kind of a special situation here. Looks like kind of like what we've done before, but just has that special point of discontinuity that makes it unique to this chapter. And that's about it. So let's try out number 3 is actually what we're going to try out. So number 2, we'll deal with one more that has a point of discontinuity. Okay. Number 3, we're going to try out right now together. So if we look at this, we try factoring. Okay, well, nothing cancels. So right away, you could just say there's no point of discontinuity, so that's kind of nice to know. And then we can also start finding some asymptotes because nothing canceled, so asymptotes are there. Okay, what do we have for vertical asymptotes? When is the denominator 0? When x equals 3 and x equals -2. Horizontal asymptotes is the bottom power is bigger, so that would be y equals 0. Your y-intercept is when you set x to 0, 0 over 0, 0 squared minus 0 minus 6, which is 0 divided by anything is 0. And if that's a y-intercept, guess what? That's going to be your x-intercept, at least one of them, because, you know, it's an x and a y-intercept at the origin. But anyways, if you're not sure, you could set the numerator to 0, which gives you 0. Okay, so why do I want to do this example? We haven't graphed one with 2 vertical asymptotes, and this is where it gets a little tricky. We talked about there was one special situation where we're going to cross the horizontal asymptote, and this is where that might happen. So let me show you what I mean. First thing we're going to do is what we've been doing. I'm going to use blue here. Oh, okay, there we go. And I'm going to draw my asymptotes as normal. Dashed lines. You can draw them by hand, or you can use this little notability tool. 3, -2, and 0 is my horizontal. So I draw those in. All right. Then I can draw in my x-intercept. Y-intercept is at 0, 0. Now this might seem strange to you, which I agree. It's on your horizontal asymptote. And typically we haven't even touched those before because usually we just avoid them. But now here's what's going to happen, guys. Okay, first of all, in a general sense, on this side and this side, you're going to either get this or this. And over here, you're going to get this or this. So kind of that typical look. Okay, so you want to know if it's above or below the horizontal asymptote. Let's do that first, actually. So at -3, remember we want to use something right next to the asymptote, not far away from it. So right to the next part of the asymptote, we have -3. So we're going to plug in -3. Now, really all you need to do is find out, is it going to be negative or positive? Because we want to know, does it land up here positive or down here negative? Your equation is this, x minus 3 over x plus 2. So just imagine you're plugging in -3. -3 over -3 minus 3 is -6. -3 plus 2 is -1. -3 over +6 is a negative. Negative. There's 3 negatives, so it ends up down here. Now, if you don't like that abstract idea, you know, the actual value is -1/2. So you could go plot it and draw from there. You do not have to plot that point, though. You could just decide, oh, it's negative, therefore I'm below the x-axis, or in this case, below the asymptote. Okay, so on the other side, we're going to do the same thing, except we're at 4. Okay, so what's 4 over 4 minus 3 is 1. 4 plus 2 is 6. So we get 2/3, aka above. So I end up doing something like that. Okay, I am done, completely done with this and with this. Again, I cannot have something graphed. It's a very common mistake. People want to do something like this. This would fail the vertical line test. So we are done with kind of those two outside sectors. We want to focus in on the middle now. What the heck is going on in here? Okay, there are basically two options. First option is it might look like a cubic. You guys kind of know what a cubic looks like. It might look something like that. Okay, or it could look something like that, a cubic going the other way. And last but not least, it could look like a little quadratic that turns around, or a little quadratic that turns around up here. So we want to figure out what's happening to the inside of the two vertical asymptotes. So I'm going to try out what's happening at -1 and what's happening at 2. Okay, again, I just want to know if it's positive or negative. So what's happening at -1? That would be -1 over -1 minus 3 is -4. -1 plus 2 is 1. Negative over a negative is a positive. So this would end up at +1/4. Again, if you want to graph that, you can, but either way, we know this graph is going, I'm going to use purple actually to continue here. We know this graph is going to go up towards infinity. Okay, because I landed at a positive, I'm going upwards towards infinity. The only thing I want to check now, is it going to go like this, or is it going to go like that? Okay, so I have to check right next door. We're going to check 2. 2 over 2 minus 3 is -1. 2 plus 2 is 4. So that would be -1/2, aka below. So again, you don't have to plot -1/2, but you can if you want. Right about there, we want to go through it and go towards -infinity. Either way, all you really had to know was it was a negative number. Okay, and we are done with our graph. Again, when you do that vertical line test, you can check. You shouldn't be hitting the graph more than once. The asymptote does not count. Those are not parts of our graph. They're technically just structure points, or structure lines, I guess I should call them. As I scan here, I'm good. Okay, at -2, there's nothing, right? Undefined. Stuff is happening between -2 and 3. I'm undefined at 3, and then I have stuff happening as I go towards infinity. So the last thing here, I just want to answer these two questions. What happens as I approach 3 from the right? So as I get closer to 3, from the right, I go towards positive infinity. Okay, what happens if I approach 3? I'm going to erase that there. Sorry, what happens if I approach 2 from the right? Okay. Oh, I meant to say, I'm sorry, this is supposed to be -2, if you guys could fix that. So what happens as I approach -2 from the right? Well, I get closer to -2, and notice I'm going towards positive infinity again. So these are not exactly matching. They're just kind of random questions. I could ask you what happens as I go towards infinity. I'm getting closer to 0. What happens as I go towards 3 from the left? I'm going towards negative infinity. So you should kind of feel comfortable with any of those approaching problems. And again, sorry, that should say -2. So yeah, guys, that's about it. I just wanted to try one with those two asymptotes again. You can make yourself a note. You can cross the HA sometimes. It's only, and I have this in the notes above, but it's only when there are 2 or more VAs. Okay, so you can sometimes cross the horizontal asymptote like we just did there, but in a general sense, it's going to either look like some type of little cubic, sorry, that's really poorly drawn, in the middle, or it's going to look like a quadratic and turn around. Could be flipped as well. So we're just going to have to test, and all you need to do is test numbers near the vertical asymptote to see if we're going towards positive or negative infinity. All right, so thanks for watching. Pause if you need to. Please bring in any questions. And yeah, thank you.